The last day is just logarithms practice. This is mostly practice for solving logarithmic equations, but there's every sort of practice in there we've been doing, converting in and out of exponential and logarithm form, change of base, solving exponential equations. There's some graphing. There's a little bit of everything, but mostly solving logarithmic equations. So I want you guys to take, 5 to 10 minutes, do number one and number two, pause the video and play it again when you are done with 1 and 2. Looking at number 1, we have 2 logs on the left and 1 log on the right of the side of the equation. So what I'm going to do first is I'm going to condense those 2 logarithms on the left side into 1 logarithm. So we're adding 2 logarithms with the same base, so we can now multiply their arguments. So that would be log of 6d squared minus 6d equals, we don't do anything on the right, that would be 3d squared plus 2d minus 4, the log of that, of course. So now we have a log of the same base equals a log of the same base, so we know their arguments must be equal to each other. So that's what we're going to do now. We're going to set their arguments equal to each other. So this would be 6d squared minus 6d. Set it equal to the argument on the right. That would be 3d squared plus 2d minus 4. Now when we look at it, we have a quadratic equation. So when you ever want to solve quadratic equations, you want to set them equal to 0 first and then have a game plan from there. So I'm going to set it equal to 0. I'm going to get everything on the left side of the equal sign so that my d squared is positive. So that would be 3d squared minus 8d plus 4 equals 0. So now I could go about this a couple ways. I could do the quadratic formula. I could do completing the square. Maybe it's factorable. I'm going to try and factor it, but you can do either way. So we need 2 numbers that would multiply to a times c, which is 12, and add to negative 8. Those 2 numbers would be negative 6 and negative 2. So I'm going to split up that negative 8d into, and we have to do it this way. Some of you guys might factor a different way when the lead coefficient's 1. In this case, the lead coefficient is greater than 1, so we have to do the AC method. So I'm going to split it up. This would be 3d squared. Now I'm going to split that minus 8d into our 2 numbers, minus 6d minus 2d plus 4 equals 0. Now we factor by grouping. Factor the first 2, factor the second 2. So the first 2 would be, take out GCF of 3d. Oops. Take out GCF of 3d. What's left over would be d minus 2. And the GCF of the second 2, remember we always want that first term to be positive. Right now it's negative, so I want to take out a negative number no matter what. And the GCF is 2, so I'm going to take out negative 2. D minus 2 equals 0. It is factorable because we have the same factor here and here. So I'll take out the d minus 2, and what's left over is 3d minus 2 equals 0. It's fully factored. So we can now do the t-chart. Set each factor equals 0. And solve for from there. You should get d is equal to 2 here. And d is equal to 2 over 3 for that second factor. Don't circle it. We need to check to see if we're actually correct. So let's go off to the right side and let's check. Make sure you always check your answers for logarithmic equations. So I'm going to plug that in. I'm going to plug 2 in first. And we have to plug it in to which equation? The original equation. So that would be log 3 times 2 plus log of 2 times 2 minus 2 equals log of 3, 2 squared plus 2 times 2 minus 4. You can plug this into your calculator, check it, or you can check it just by looking at the arguments. As you see, every argument's going to be greater than 0. Sorry, every argument's going to be greater than 0, so that's going to work. And let's check our other one, our other possible solution, 2 over 3. So that would be log of 3 times 2 over 3. That one's good, our argument's positive, greater than 0, plus log of 2 times 2 over 3 minus 2 equals log of 3 times 2 over 3 squared plus 2 times 2 over 3 minus 4. Now, if we take a look at this one, this argument here is going to be negative. So this is going to be rejection. You could also check it by plugging one side into the calculator, then plug the other side into the calculator. They should be equal. But our only answer here would be D is equal to 2. And once again, you could have not factored that if you didn't want to. You could have done completing the square. You could have done quadratic formula. I think especially when that Lie coefficient here, let me highlight it, when that Lie coefficient or quadratic, that 3, whenever it's greater than 1, I think it's easiest to factor if you can. And then if you can't factor, quadratic formula. But you can do completing the square. It does work completely fine for this. Just involves a little bit more steps. So let's look at number 2. Here we have 2 logs with the same base on the left. They're being subtracted, and a constant on the right. So what I'm first going to want to do here is I'm going to condense those logarithms on the left side of the equation. So I'm subtracting 2 logarithms with the same base. That means we can divide their arguments and write it under 1 log. So that would be log base 3 of x to the 4th plus 51x squared minus 27. And that all goes over 2x squared plus 1. So that equal to 3. So now we have this equation in logarithm form. Let's get it out of logarithm form and turn it into exponential form. So our base is 3. So is our exponent, because that's what the log is equal to. And that's going to be equal to our argument, x to the 4th plus 51 x squared minus 27, all over 2x squared plus 1. So at left side, let's make that 27, a little bit easier to work with than 3 to the 3rd, equals x to the 4th plus 51x squared minus 27, all over 2x squared plus 1. What I'm going to do here is I'm going to cross multiply. Really think of that 27 being 27 over 1. And that would be 27 times 2x squared plus 1 equals x to the 4th plus 51x squared minus 27. I'm going to keep on simplifying this. So I'm going to multiply that distribute that 27 in to both numbers inside, no, both terms inside that parenthesis. So that would be 54x squared plus 27, all equals x to the 4th plus 51x squared minus 27. Get everything on one side. I want my largest degree term to stay positive, so I'm going to get everything on the right side. So it'll be x to the 4th. When you subtract 54x squared on both sides, you get minus 3x squared. And we subtract 27 on both sides, you get minus 54 equals 0. This is factorable, so this would be x squared, 2 numbers that multiply to negative 9. sorry, negative 54, and add to negative 3 would be negative 9, positive 6 equals 0. I'm going to come up here to the top and rewrite that because we need a little bit more space here. Minus 9. Then x squared plus 6 equals 0. You could actually break this down and solve it now. I'm going to continue factoring. That x squared minus 9 is a difference of two perfect squares. So that would be x plus 3, x minus 3 times x squared plus 6. It just helps me to completely factor it because it limits the mistakes I'm going to make. Because sometimes I might forget that positive and negative. So if you completely factor it, it's really going to limit your mistakes. So it's fully factored out. Now I'm going to T-chart. So I'm going to set every single factor equals 0. That's going to be x plus 3 equals 0, x minus 3 equals 0, and x squared plus 6 equals 0. When I solve for them, I get x equals negative 3. I get x equals 3. And here I get x squared equals negative 6. When I square root both sides, I get x equal to plus or minus I rad 6. Can't have an imaginary number inside the logarithm. That's not going to work. So we can reject that right away. So our two potential answers are positive and negative 3. We just have to make sure we check that. So let's check both answers. And you have to make sure you plug into what equation? The original equation. So that would be log base 3. I'm going to check negative 3 first. Of negative 3 to the 4th plus 51 times negative 3 squared minus 27 minus log of 3, hopefully we have enough space, 2 times negative 3 squared plus 1 equals 3. Whew. And if you were to plug that into the calculator, or you can check the arguments, all the arguments are going to be positive. And the calculator should show also when you plug in that left side of the equation, you're going to get 3. So let's also check that for positive 3. Log base 3 of 3 to the 4th plus 51. 3 squared minus 27 minus log base 3 of 2 times 3 squared plus 1. And that should equal 3. When you plug that in the calculator or you check all of the arguments, they're all going to be positive. The calculator will also spit out the answer 3. So that works. So our final answer is x equals plus or minus 3. You can write it as plus 3 and minus 3. You can write it as 3 and negative 3. Anything you want to write it as, just make sure the two answers are positive 3 and negative 3. So that is it for me talking. The rest is just practice with logarithms and take your time on these. I believe there's about 25 questions, and that's it.